There is no requirement in the National Electrical Code or any other electrical code that mandates the use of an elevator shunt trip in Rhode Island. Elevator shunt trips are safety devices designed to disconnect power to an elevator in specific emergency situations, such as activation of a fire alarm or detection of a sprinkler flow. The rationale behind a shunt trip is to prevent the elevator from traveling to a floor where there might be a fire, trapping occupants or hindering firefighters. While the National Electrical Code doesn't explicitly require shunt trips for all elevators in every jurisdiction, it does provide guidelines and standards that influence elevator safety. These guidelines are often supplemented by local and state regulations, which can vary significantly. To determine the specific requirements for elevator shunt trips in Rhode Island, one should consult the Rhode Island State Building Code, which typically incorporates and amends the International Building Code, and any specific regulations set forth by the Rhode Island Department of Labor and Training, Division of Occupational Safety and Health. These local amendments may include specific requirements for elevator safety that go beyond the National Electrical Code's minimum standards. It's important to understand the interplay between the National Electrical Code, the International Building Code, and local amendments. The National Electrical Code focuses primarily on the safe installation of electrical systems, including those within elevators. The International Building Code, adopted and modified by states and municipalities, addresses the overall safety of buildings, including fire safety and accessibility, which may involve specific elevator requirements. Local amendments are critical because they tailor the codes to the specific needs and priorities of the jurisdiction. They might address unique geographic factors, historical building practices, or specific safety concerns that are not adequately covered by the national codes. In the absence of a specific mandate in the Rhode Island State Building Code or other Rhode Island regulations, the decision to install an elevator shunt trip might be based on a risk assessment conducted by the building owner, a recommendation from an elevator maintenance company, or a requirement imposed by an insurance provider. These assessments often consider factors such as the type of building, its occupancy, the height of the building, and the potential consequences of an elevator malfunction during a fire or other emergency. While the National Electrical Code doesn't mandate shunt trips, it does contain articles relevant to elevator electrical systems. Article 620 covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chairlifts. This article provides detailed requirements for the wiring, overcurrent protection, grounding, and control circuits of these systems. Although Article 620 doesn't specifically require shunt trips, it establishes the foundation for safe electrical installations within elevators, which can influence the design and implementation of safety features like shunt trips. For example, Section 620.51 addresses disconnecting means, which are essential for safely de-energizing elevator circuits for maintenance or emergency purposes. A shunt trip could be integrated with the disconnecting means to provide a remote shut-off capability. Similarly, Section 620.55 covers overcurrent protection, ensuring that elevator circuits are protected from excessive current that could lead to fire or equipment damage. The proper selection and coordination of overcurrent devices are crucial for the reliable operation of elevator safety systems. In addition to the National Electrical Code and the International Building Code, the American Society of Mechanical Engineers, or SME, develops standards related to elevator safety. The SME 17.1 Safety Code for Elevators and Escalators is widely recognized and often referenced in building codes. While the SME 17.1 is not itself a legal requirement unless adopted by a jurisdiction, it provides comprehensive guidance on elevator design, installation, operation, inspection, testing, and maintenance. This standard may influence the decision to install a shunt trip or other safety features, even if not explicitly mandated by code. It is crucial for building owners, elevator contractors, and electrical engineers to stay informed about the latest editions of the National Electrical Code, the International Building Code, SME 17.1, and any applicable state and local regulations. Code requirements can change over time, and it's essential to comply with the most current standards to ensure the safety of building occupants. Furthermore, it's important to maintain accurate records of elevator inspections, testing, and maintenance. Regular inspections can identify potential safety hazards and ensure that all elevator systems are functioning correctly. Proper maintenance can prevent malfunctions and extend the lifespan of elevator equipment. In conclusion, while the National Electrical Code doesn't explicitly require elevator shunt trips in Rhode Island, the decision to install one should be based on a thorough understanding of the Rhode Island State Building Code, any applicable local regulations, and a comprehensive risk assessment. Staying informed about the latest code requirements and maintaining accurate records of elevator inspections and maintenance are essential for ensuring the safety of building occupants. The absence of a specific requirement in the National Electrical Code does not preclude the possibility of such a requirement existing in local or state codes. Therefore, the appropriate authorities in Rhode Island should be consulted to confirm the current regulations regarding elevator shunt trips. The NEC provides minimum safety standards. Local jurisdictions often amend these standards to address specific needs or concerns. Therefore, a thorough investigation of local codes is essential to determine the requirements for elevator shunt trips in Rhode Island. Firstly, consult the Rhode Island State Building Code, which is based on the International Building Code. Secondly, contact the Rhode Island Department of Labor and Training, Division of Occupational Safety and Health. Thirdly, review any local ordinances or regulations that may apply to elevator installations in Rhode Island. Consider the specific type of building and its occupancy. High-rise buildings or buildings with vulnerable populations may have stricter requirements. Consult with a qualified elevator contractor or electrical engineer familiar with Rhode Island codes. They can provide expert guidance on the applicable requirements. Document all findings and decisions related to elevator shunt trips. This documentation can be helpful for future reference or in the event of an inspection. Remember that code requirements can change over time. Stay informed about the latest updates to the NEC, the International Building Code, and Rhode Island regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by states and municipalities as the basis for their electrical codes. However, local jurisdictions often make amendments to the NEC to address specific needs or concerns. Therefore, it is essential to consult the local electrical code in addition to the NEC. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for certain types of equipment and occupancies, such as elevators, healthcare facilities, and hazardous locations. Article 620 of the NEC covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chairlifts. This article provides detailed requirements for the wiring, overcurrent protection, grounding, and control circuits of these systems. While Article 620 does not specifically require elevator shunt trips, it does establish the foundation for safe electrical installations within elevators. Section 620.51 addresses disconnecting means, which are essential for safely energizing elevator circuits for maintenance or emergency purposes. A shunt trip could be integrated with the disconnecting means to provide a remote shut-off capability. Section 620.55 covers overcurrent protection, ensuring that elevator circuits are protected from excessive current that could lead to fire or equipment damage. The proper selection and coordination of overcurrent devices are crucial for the reliable operation of elevator safety systems. The International Building Code, or IC, is a model building code developed by the International Code Council, or IC. It is widely adopted by states and municipalities as the basis for their building codes. The IBC addresses a wide range of topics related to building safety, including fire safety, structural safety, and accessibility. Chapter 30 of the IBC covers elevators and conveying systems. This chapter includes requirements for the design, installation, and operation of elevators. The IBC may reference the NEC for electrical requirements related to elevators. The American Society of Mechanical Engineers, or ASME, develops standards related to elevator safety. ASME A17.1 Safety Code for Elevators and Escalators is widely recognized and often referenced in building codes. While ASME A17.1 is not itself a legal requirement unless adopted by a jurisdiction, it provides comprehensive guidance on elevator design, installation, operation, inspection, testing, and maintenance. The Rhode Island State Building Code is based on the International Building Code. Therefore, it is essential to consult the Rhode Island State Building Code to determine the requirements for elevator shunt trips in Rhode Island. The Rhode Island Department of Labor and Training, Division of Occupational Safety and Health, may have additional regulations related to elevator safety. Contacting this agency can provide clarification on any specific requirements for elevator shunt trips in Rhode Island. Local ordinances or regulations may apply to elevator installations in Rhode Island. Check with the local building department or fire marshal to determine if there are any such requirements. The specific type of building and its occupancy can affect the requirements for elevator shunt trips. High-rise buildings or buildings with vulnerable populations may have stricter requirements. Consulting with a qualified elevator contractor or electrical engineer familiar with Rhode Island codes can provide expert guidance on the applicable requirements. They can assess the specific situation and recommend the appropriate safety measures. Documenting all findings and decisions related to elevator shunt trips is essential for future reference or in the event of an inspection. Keeping accurate records can demonstrate compliance with applicable codes and regulations. Code requirements can change over time. Staying informed about the latest updates to the NEC, the International Building Code, and Rhode Island regulations is crucial for ensuring compliance and maintaining elevator safety. The absence of a specific requirement for elevator shunt trips in the NEC does not necessarily mean that they are not required in Rhode Island. Local or state codes may have additional requirements. Therefore, thorough research and consultation with relevant authorities are essential to determine the applicable requirement. Elevator shunt trips are safety devices that disconnect power to an elevator in the event of a fire or other emergency. They are designed to prevent the elevator from traveling to a floor where there is a fire, trapping occupants, or hindering firefighters. While the NEC does not mandate shunt trips for all elevators, they are often required in certain types of buildings or in specific situations. The decision to install an elevator shunt trip should be based on a thorough risk assessment and consultation with qualified professionals.